Welcome everyone to the one of the afternoon sessions on track C of the Data Summit Connect 2021, and you're joining on real world data ops, where you'll be hearing from Jatin Hansoty, who is the Director of Solutions Architecture from Zaloni, as well as Eric Schiller, who is the lead data engineer from Excella. Eric does bring uh, years of varied IT experience to projects where the data and software engineering intersect. And while he's not immersed in data and engineering, he spends his time with his family, watching hockey, go Capitals, craft beer, and he cannot wait to travel again. And just a reminder that you can post questions in the feedback chat at the end of the session. I'll share them either with Eric or Jatine or both. And don't forget to head on over to the networking session to continue those conversations with Eric and Jatine. And in the meantime, take it away, Jatine.
Hello, everyone, and welcome to this webinar. Thanks for your time. I'm excited to be here talking about DataOps and governance. My name is Jatin Hansoty, Director of Engineering at Zaloni. Here at Zaloni, we are in the business of enabling data management for customers to help them get from data to value. All of this in a manner that's repeatable and scalable. And that is really the value proposition for DataOps, to realize a supply chain for data that is efficient and effective. Now, we've been lucky to work with a number of large enterprise customers, and they have really complex and interesting data landscapes. Our data management journey starts with addressing data sprawl and knowledge fragmentation. Enterprises have a lot of different sources, internal, external, third party, across a variety of business and technology platforms in various stages of adoption and maturity. And usually the knowledge about the data is siloed across organizational boundaries. So we help drive data platforms where the assets are managed, secured, and governed so that the consumers in LOB and CD organizations can truly focus their efforts on business efficiency, operational savings, new opportunities, instead of nuts and bolts like data discovery and wrangling. We've also been very fortunate in terms of industry validation through awards. And here's some that we've won over the last year or so, validating the approach that we're taking with our DataOps platform. Let's start with a broad view of the challenges that exist in modern data environments. So the first one is complexity and sprawl. Now, there have been seismic shifts in the digital world, and there are always continuous changes along business modernization and business transformation. This results in a lot of complexity in the data landscape of an enterprise. And this is not a static problem. The complexity keeps increasing because of the pace of change in the world around us. Inefficient data pipelines. We see single-use pipelines with purpose-built scripts and code. This works okay for small platforms, but the lack of reusability and automation makes it hard to scale up when there are hundreds of data flows to be orchestrated. Inconsistent governance is a third one. Now, enterprises do have well-defined policies and procedures for data acquisition, retention, access methods, but with organizational and technology changes, cloud migrations, hybrid architectures, the need for agility and self-service across teams that are traditionally siloed, it's harder to standardize policies and maintain relevance. So the uniformity of data governance is important to address early. And then lack of self-service access is last but certainly not the least. It's the ability to make refined and curated data sets visible to consumers and then available through self-service. Gone are the days of the patient consumer. In today's world, everyone's biased towards immediate availability of commodities, and the same is true for data as well. Now, DataOps is a broad, complex area, so where do we start? The first step is to assess the current state, the data assets, the pipelines, the producer and consumer groups, consumption methods, how is the value being derived for existing business priorities. This activity also helps refine tactical and strategic goals for the company's DataOps initiative. So at Zaloni, we try to look at all these various initiatives that a customer has done or is doing, and then map it into a standardized maturity model like this one. As with other maturity models, this one provides a framework to plan a roadmap, in this case, a DataOps roadmap. So I'm just going to go through these stages left to right, and they're sort of written out to be incremental, but in practice, when these do get adopted, there's multiple tracks can go on in parallel. So some business units can be further ahead than others. So the first stage is unmanaged. In this stage, you're serving your use cases, but in an ad hoc manner. So the work is being done, but as needed. Requests coming from different consumer teams, LOBs, a project gets spun up, data discovery, acquisition, data flows and stores are built to spec. And then when the next use case comes along, there's a similar pattern of execution. So in this kind of environment, there may be some incidental reuse, but there isn't a systemic reuse model for the assets, the processes, or the policies to manage the data. The net effect that's perceived from the outside is that even though it takes a lot of work, the time to value is too long. And then that becomes a hurdle for business transformation, where it needs a large volume of these use cases to be implemented. The second stage in this maturity model is a managed stage. Here, there's a data discovery process in place for enterprise and third-party data, a common catalog, a view of the technical metadata that's visible across a platform. Now there's ability to see and reuse these data assets. So that's a key aspect of managed, the common reusable data assets. And this is an improvement over stage one. Common visibility, common control, and hence reduced duplication of assets. The third stage is the operationalized stage. This is where it starts getting exciting. Here, the data processing pipelines themselves that are built to be reusable, and the principles of DevOps applied to these pipelines, automation, CI/CD. Within the stage, there's also progression from one extreme, developers writing the pipelines from scratch, to the other extreme where data engineers are composing these from building blocks in a low-code, no-code manner. So in this stage, the automation and the reuse of the pipelines themselves can result in significant cost efficiency and, most importantly, scalability. More throughput through the platform means reduced operating costs, reduced duplication of effort. The next stage is the govern stage, and you can see that at this stage, the scope of DataOps has expanded beyond the nuts and bolts of data discovery and acquisition and preparation, and the consumer audience is now included in the scope of governance. In this stage, the focus is all about trust. The concerns are data quality controls, masking and tokenization of privacy, secure data access, curation by experts and the user community, and complementing this trusted data platform is self-service provisioning so that these assets are consumable in a frictionless way. At this stage, we see a leap in reducing the time to insight and really leveling up the ROI for the organization. The final stage to the right is the, we call it the augmented stage. Here where we use advanced technologies like machine learning to make data management better. The focus in this stage is on infusing intelligence into the data supply chain. For example, automated data classification to surface semantic properties of the data. Say sensitive data is identified so that follow-up actions like it can be automatically obfuscated or tagged for additional approval on a provisioning path. Another example is, relations between data sets can be inferred based on some of these semantic properties that we get from classification or usage patterns. And these can be used for recommendations to end users. I see you have a project to correlate marketing outreach data set with your online shopping activity. So maybe you're interested in these loyalty data sets from your flagship brands. And as you can imagine, as a consumer, they'd be thrilled because now they are able to improve and make their reports, their analysis more meaningful. And the platform enables them to see data sets, refine data sets that they didn't even know existed. So that's how we'd get to a frictionless delivery of timely, trusted data through intelligence and software. Now, this is a journey. Now, we think about DataOps as a cycle of continuously improving the supply chain. So we use this infinity loop representation. A good place to start looking at this are the two key constituents: the data engineers and data stewards on one side, and the consumers, the data analysts and scientists on the other side. The collaborative data catalog in the center is that single pane of glass that connects the people, the processes, and the data. Moving around the loop, there are numerous functions along the data supply chain on both sides within the purview of each of these user groups. And all of these contribute back to the catalog. Profiling and classification, data quality checks, mastering, entity resolution, lineage, dynamic metadata like labels, owners, business glossary, all of them feed back into the collaborative data catalog. On the right-hand side, the data marketplace is a consumer portal for the catalog. Data prep, enrichment, annotation help enhance the level of domain knowledge in the catalog and also add back derived data sets into the enterprise corpus. Now, it goes without saying that establishing and succeeding with a DataOps initiative requires an iterative approach and an agile mindset. So in the next slide, I want to quickly talk about a specific governance pattern for organizing a data platform in a way that will help with data supply automation and building that collaborative data catalog that we talked about. So we call this Saloni's end zone governance. Now, first, I'll start with sort of a disclaimer. This diagram shows 4 zones, and I'll walk through them, but this is just an example. In a deployment, the number and the type of zones depend on the needs of that deployment, of the use cases that are the usage use cases and the governance model for that customer. The raw zone consists of the data before any downstream processing. Now, what makes up raw data is dependent on the source. For a sensor stream, the raw data may be binary payloads, extremely unstructured. While for an operational database source, the raw data would be highly structured and typed. A data pipeline can apply data quality checks, again, tokenization, standardization, and any other actions that are needed for creating those trusted data sets that are then certified for use by the broader organization. So these are represented by the arrow from the raw to the trusted zone. Then going to the right from there, the data sets could be blended, aggregated, and otherwise transformed for the refined zone. These are now reusable data assets that are closer to the needs of the customers. They're more meaningful. And as I mentioned in the previous slide, the consumers themselves may be producers of new data sets. And then the last zone shown over here is for experimental sandboxes. This is a common scenario that we see at most deployments, that you create a sandbox, data is provisioned into it for innovation use cases. So these zones drive who can view and extract data, what processing actions are appropriate, and assurance as to the quality of the data within the zone. So a zone is a governance construct that then policies can be defined around. Now, so far, I've not talked about the Zaloni product. So this is how Arena, our data management product, is structured to enable unified DataOps. The core functionality, I'm going to focus on the center of this diagram, those three pillars. The core functionality of Arena is represented in these three key areas: catalog, control, and consume. Catalog is where data is inventoried, wherever it may exist. Augmented metadata, which includes technical, business, operational attributes that are contributed by both human collaborators and DataOps pipelines. And profiling and classification add additional perspective to these data sets. The control pillar includes data inspection and actions to apply governance policies. Data quality checks, masking and tokenization, detecting bad data, and data lineage. Now, within sort of the control domain, there are other data processing actions that are available in the palette. With a visual designer, with this slide shows a few of them that are focused on governance. The consume pillar caters to providing consumers with a rich marketplace experience driven through the catalog to find, enrich, and provision data in a self-service manner. Within the product, within the platform, all of this is happening within the context of governance zones, role-based access control projects, so that multiple teams can work concurrently within the same environment, dashboards and alerting, reusable pipelines, and the other fundamental capabilities for DataOps pipelines that are behind underlying these three pillars. This is our final slide of the presentation, and it's mostly a recap slides. As you think about the outcomes from DataOps, keep the maturity model in mind. The progression through the different stages of the maturity model result in increasing levels of value and ROI. Once we get closer towards the end, a streamlined DataOps discipline will result in unified, efficient, trustworthy, and frictionless self-service data platform that will help accelerate that time to insights. And with that, thank you, everyone.
Okay. Thank you, Jatin, for that very informative session.
Oh,
and I will be passing over the floor to Eric. Again, Eric Schiller is the lead data engineer of Excella. Take it away, Eric.
It just means you're YouTube.
So good afternoon, everyone. I am just getting my slides going here. So give me a couple seconds. Hopefully everyone is doing good. I know we're kind of on the second half of the day. Hopefully everyone's gotten time to get a break and kind of get some, sustenance, get some food in, just kind of get a breather, because I know we got a long day and more tomorrow, but it has been good stuff so far. Okay. Review. And 2 seconds, because everything is different when you're live. Okay. Okay, just give me a second to employ this cool trick I just learned on sharing with PowerPoint. That's okay. On screen share. Apologies, I'm having technical difficulties, so just give me a second. Okay.
Yep. Thanks, Eric. We see your slides.
What does it do?
Thank you so much. Yeah, I am. So yeah, I'm Eric Schiller. Just kind of want to talk here about what I want to call real world data ops. Unfortunately, I'm not at my normal place where I've been presenting from, so I don't have a second monitor and had to work this out. Okay. Cool. Okay. So what am I why am I here? Where am I coming from? So I'm at Excella. We are a consulting company. I'm one of our lead data engineers. I've been in IT for a little over 20 years now. I technically started as a software engineer, but I've worked in so many different domains, whether it's doing audit software, content management, telecommunications, any number of other things. I've kind of lost track of insurance. In general, probably the biggest, most common thing across my entire career is I have been working with databases, working with data, often pairing up with the analytical side of things once we're off into the reporting and business intelligence world. And eventually, just to the point of where I was helping them design these things, kind of slowly one day realized, oh, what I'm doing is not actually traditional web development anymore. I'm a data engineer. I just didn't know the word for that. So I've just kind of leaned into it. So the last 4 years, especially, is how long I've been with Excella, and being in the consulting space is a good and bad thing, because the good news is if you get bored with whatever you're doing, you get a chance to work on another project soon enough. The downside is whatever like kind of crazy things I'd seen before, I've accelerated all of that. So I've seen a lot of things, good and bad. And that's kind of how I got here today. So with that, probably the last thing I just rolled off of was about a year and a half of doing, usually it's the usual data migrations or just kind of helping build like a data warehouse or something like that. This was an entity resolution project, specifically trying to piece together people's identities, which, as it turns out, is a really complicated and it's actual own domain. I've had a couple of Amazon, for instance. I think I've had this problem with a different large company of that same size, where they've even had trouble solving this correctly in a case where they actually own all the data, and different silos have kind of made it hard for me as a consumer to be two records that I know are identical to convince them that no, really, I'm the same person. I'm on the phone with you. Now, I'm coming from doing this from a large federal government customer where some of the cases are they don't own the data because they're collecting it to process folks' cases, but they're also have internal silos. Plus, there are also other agencies they are sharing data with. So, that many more levels of complication. The good news about all that is, hey, DataOps, I'm excited. I have this great stuff in my tool belt. I first heard the term in 2017, where it was, again, one of these cases of I already was doing some of it as much as you could in 2017. It was the first time I'd ever had a word to put towards it. I was super excited. So last year I got to tell everyone how excited I was when I talked about just sort of the DataOps manifesto and just kind of some of the cool stuff I'd learned, out of the general space. Today I'm here to talk about what happens when excitement hits reality. So with that, before I want to go too far into it, I do want to clarify when I say DataOps what I am referring to. In this case, I know the term has gotten a little bit more mature and still is kind of getting defined by the industry. But then, I've kind of started seeing, especially in the past year, kind of what I refer to as the younger, sexier cousins, MLOps and AIOps. I just want to give kind of a distinction. So the main distinction I would say, again, we're talking about the industry still trying to figure this out, is that DataOps is pretty much always concerned with the pipelines and platforms of how data is passed along and then how it is in fact stored. MLOps, AIOps, any other variation of that tends to be more concerned with delivering high quality and repeatable training and then the actual deployment of models and kind of just making sure that the stuff is operationalized. There's a ton of overlap depending on what you're reading. It may become kind of unclear where the differences are. It may become where you're kind of like, well, why do we even call things MLOps if MLOps can just fall under DataOps? And what I've noticed is that there is a bunch of overlap. Pretty much most of your assumptions are correct if you're thinking that. But at the end of the day, it is kind of that distinction of what I noted. It's that there are some very specific pieces to both. DataOps tends to be how you deliver and store data for any kind of analytical project, whether it's more traditional analytics of kind of what's going on now, or like, let's have these cool, let's have a dashboard and have a lot of like visualizations behind it. Whereas, of course, the MLOps side of things is once the data is there, doing the what if pieces and like the more kind of structured, focused computer side of that. I will concede for now on the fact that data ops actually means something a little more specific. I used to tend to run with it as being the overarching, but I'm willing to concede on that. We're all about change and being agile, so I can be too. Okay. In the spirit of that, I actually ended up updating this talk probably about a week before the conference. After I saw a talk, one of my colleagues who's an agile coach went into something called the Kinefin framework. If you're not familiar, Kinefin is just kind of a sense-making framework. I think it came out of IBM sometime in the late 90s. And it is something that it's a Welsh word meaning habitat or like home or environment. And the idea behind it is it puts every problem you could run into 4 different domains. 2 of them are completely unordered. Those would be complex and chaotic that you see on the left. 2 of them are ordered, which is complicated and clear. Essentially starting at chaotic and going clockwise, they get to simpler and simpler to the point of it's easier to deal with. Chaos is exactly what you think it is. There are literally no rules whatsoever. Something like a disaster area, especially when it first happens, is considered something that would be chaotic, where you just need to act and then kind of figure it out from there. Complex, there are rules, but they are constantly changing, and by observing the system changes. Something like an ecosystem, like the Amazon, would be considered complex. You can study it for 5 years right now and come up with some really great ideas. Go back 10 years from now, a lot of them don't apply. Now, once you get to the ordered side, complicated is something where at first glance, you may not know what's going on, but you're now in the domain where people can be experts. They've seen these things before. Check engine lights on your car are actually a great example of you have to understand what's going on, but once you have a general idea, an expert can kind of go in and troubleshoot and figure out very close to the exact problem. Some parts of medicine kind of fall into this. Clear is basic arithmetic. Everybody already knows how this works. The rules don't change. They're very clear. We can just kind of work this out. It's commoditized. Guess where most analytics projects fall? That's right. If you are lucky and it's a good day, we're dealing with complicated. That said, most standard software projects can tend to fall into complex as they go on over time. And of course, analytics often driven by already existing complex software over time. So yeah, a lot of our stuff falls under complex. It is our job to kind of push those things, break those things down. I'll get more into that later and just get things to the complicated. So back to that entity resolution project I was talking about, we had 8 or 9 different source systems to start. We were given, they sort of understood Agile, but I think we have a lot of the constraints on the project that I'll kind of get into a little bit later. But in general, 8 or 9 different source systems. 1 to 2 of them, I would say, were actually intended to be person-centric. They just didn't have all the people or all the information about a person. The rest of them were case management. So the person you're looking at might be one of many people on a case. It may be that they have other information. They may have other family members. They may have legal people they're working with. They may have any number of things where there are other people listed. It could also be that the information is self-produced, not always reliable. Sometimes it may be that it's produced by someone who knows the person, any number of places. And you need to take whatever you can out of there, piece together existing people. You need to do deduplication and do these kind of things and eventually squeeze out, this is what we know about individual people. It's a pretty complicated, it's a pretty complex project in that sense. Because not only people change over time, their situations change. Different times you're asking questions about the data, the data may have had different answers. So I was excited when I got onto it. We were going in, it was like, hey, this is great. I can showcase DataOps. And it's one of those things where I was like, cool. And as I thought about it, though, I was like, how do I explain DataOps to my client? How do I explain it to even the other sort of the software engineers on the project versus like the data engineers and data scientists who understood why data projects can be different, even though there's definitely some overlap of what we can do and automate and really understand these things. There's also a lot of cases where to a software engineer, they're gonna be like, well, what do you mean you don't just do this? Like, why don't you follow this basic DevOps principle? And the answer is because it's not that cut and dried. So I was like, cool, let me kind of give some like template, let me kind of, help get everyone started. And then it occurred to me, that's not as cut and dried either. There is no one size fits all solution. Data projects change by name, over time, data is messy. So I thought about this and I thought, wait a minute, if I were to write this, which is the emphasis of this talk, as it turned out over a year ago, was it's more like when you see, if anyone's ever seen like the Rubik's Cube, like how to solve it, they have entire books on this, and everything is, okay, if your thing, if your situation kind of looks like this, get to this point and then we'll talk. And then you get to that point and then it says, okay, it probably looks about like this and it's in this range of shapes. Now get to this point, but they can't tell you because there's thousands of combinations. Sports teams like have playbooks like this that constantly change based on what team they're playing, things like that. But there are known situations where they say, in this case, doing this works a lot of the time. Try to get here. You have to figure out how to get here. That's where the expert. You're trying to push out of the complex into the complicated. Or my favorite example of what this would look like, and the title of this is, if anyone remembers, I'm kind of a child of the 90s. I'm not a video gamer now, but I definitely played a lot more growing up in high school. There'd be a lot of these games before the internet exploded where they'd have their own magazine, like there'd be books dedicated to like, here's the secrets guide. A lot of things like Nintendo magazine would have walkthroughs, things like this, stuff that's now on YouTube. So you kind of have that as just kind of such a thing. So I thought, yeah, that's kind of what DataOps is. There's a lot of checkpoints. There's a lot of presentation. Like I can get to this point. I don't know how to get to this point. I have to do some discovery and work with it. I have to iterate. Once I'm here, I can get you to the next point. So that's kind of how I feel about it. There's no clear map, but there's places where we can make things a little more predictable, which is great. And as you think about it, yep, Shanto, you're not playing a video game. This is actually more like the sports analogy where you have a whole team. You have different people doing different things. In this case, you have folks in a cross-functional team because, again, we're also taking from Agile as we're doing DataOps. Yes, there are constraints in the real world. There are often a lot of them. Sometimes there are ones you can control. Sometimes there are ones your team has zero control over, especially myself as a consultant. They are not an outright wall. They are simply constraints. They're more of a thing to go around or just kind of lean into and work with as you need to. So on our journey, let's kind of pretend, I always kind of think about this in the back of my mind. I played a lot of Zelda growing up. You're walking around a map, you're fighting monsters, you're going and learning secrets, things like that. You have to kind of solve some puzzles along the way. On the start of this, in any of those games, in the start of maybe you're, even think about this in real life. If you're like a Lewis and Clark kind of like, I'm in a place I don't quite recognize. I know what woods look like. I know where rivers got to go one direction. Let's go with that. You start walking around, you figure out, you take what you know, you kind of work with it, see what works. So when you're starting on a data project, you're pretty much always in that discovery phase. And one of the absolute, biggest trade-offs is I need to figure out what I'm doing. I need to understand the data, the landscape, but I also need to present to my customer pretty quickly, hey, I'm going to show you some confidence. I want to show you something so I can get feedback on it. With that, and this is even applies to a lot of internal IT departments, especially if you're trying to, do a major sea change of moving to a DataOps kind of just mindset. So while you're setting up the tools, while you're doing these things, one of the first things you can do, and probably one of my favorite tools, is mock data. I cannot stress enough. Sometimes it just takes a long time to get production data, whether it is in a standpoint of you're dealing with a lot of security constraints, a lot of silos, could be any number of things. It takes a while. Sometimes you can look at it, but you can't extract it. Work with mock data. Separate out the way you process the data from the content of the data. Work them in parallel. Eventually, you do have to integrate, but if you have something that looks realistic, if possible, get a copy of production data that it's a copy, it doesn't get to change. You may have to strip out proprietary information. That's okay. It's a start. Otherwise, there are data generators out there. You'll usually have access to a schema layer where you have data. Some data generators even can look at, again, a copy of data or at least the schema and use machine learning to kind of make up really good guesses. Some of them just kind of blindly chug things out based on your data types. Worst case scenario, you have to write your own. Thankfully, hopefully you have some software and some data engineers on the team who are, of course, we're developers. We also understand data, run with our strengths. Even data analysts, a lot of folks, they work in Python, they work in R. They can help, reverse engineer with a little bit of guidance. Otherwise, again, we're making a map or a team working in parallel. you know the structure of the data. As you're starting to talk to people, you can already start creating that map of data cataloging. There's a lot of tools that out there already. And again, some of these things are depending on the size of what you're working with, and also the data storage, especially if it's a structured, more relational databases, or hopefully like a well-sized data lake, well-organized data lake. You can crawl and find out what these things are, and then just kind of backfill from anything that's not commented or defined. Start creating the data catalog. Start creating your canonical models, making sure that everyone's talking the same language across the project. In that entity resolution project, we came up with a basic JSON structure because I said it was kind of a near real time replacing a batch system. This was a close to streaming. Essentially, it was running about every 20 minutes. With that, we are at the point where, essentially it was like, hey, what we can do is we can take that and just kind of run with it. We'll create the basic structure at each stage of the way. We know it's coming into that JSON. That became our canonical model. And again, where possible, make it, and then that project didn't work, but a lot of cases I've worked with pulling things out of a data lake or a data warehouse. We get this idea of schema on read. We loosely couple our schemas. We try to say, hey, you know what to do with it. You're more likely to be self-serve. We want to make you that option. You're going to have to iterate on these things a lot, but you've created that first general map. It might have here be dragons and a lot of fuzzy parts on it, but at least you can present that to your customer and say, hey, are we close? The next one I run into a lot as a constraint is tool preferences or lack of ability to use them. The extreme that I like to have is folks who are like, just get it done, and here's your price checkpoint, and here's our overall environment, go nuts. Then it's more of an analysis paralysis becomes your constraint, what you can work or what you know how to work on. The flip side of that becomes, no, here is the long list of things that are either not approved or you ask us, and if it is not on this list, you don't get to work with it and it has to go through security review. Or no. In our case, somewhere in this project, we had to use Databricks. The CTO had a very large amount of sunk cost. Databricks was the host and front end of the data lake. We kind of had to work with that to get data out of the data lake. It was a weird use case for part of the project. It was a terrible use case to use Spark of any nature. Again, we were trying to do a little more streaming, a little bit less batch. For part of it, it was totally a reasonable process, but it was just kind of a weird use case. We ran with it. We said, okay, you know what? Databricks has managed Spark. It's actually a little bit nicer to do some of these other things. Let's run with it. And a piece that was essentially a lot of upfront processing to squeeze down to a message to go to a Kinesis stream worked really well, and it worked really, really fast. So we ran with it. All the code we were running against it was either SQL kind of running, to extract data, and then just Python using PySpark within the Databricks environment and passing that JSON out. We took what it did and we just ran with it and, used it to its strengths. Otherwise, there were things where something like Airflow to do orchestrations and some of the other jobs was not realistic. We used Jenkins to automate things, and otherwise the Databricks scheduler and some other pieces there. So that was kind of where we went with that. As far as other things, we were able to use a lot of the really common cloud services. We were using AWS. We were able to use Lambda for some other pieces. We had to run some regular computing instances. We were able to deploy things on containers, super basic stuff that we didn't have to worry about security review for. Code first, again, it's generally a good idea anyway, but as much as possible. Analytics is code, lean into that, actually write code. Finally, things change all the time. We're flexible, data changes, guess what? So does your environment. Software gets approved, sometimes features get added, things change, go take a look. Okay. Oh, why is this slide not advancing? Okay. So this one tends to be a little bit more of less the technical folks, a little bit more at the analysis folks and kind of requirements. Do your analysis at the same time. Again, this is the content of the data, less of the how to produce it. You're gonna be wrong. The sooner you're wrong, the better. Analyze quickly. Everyone's been there at 3 a.m. when the analytics are just wrong. That's why we talk about DataOps. So with that, interview your experts early. Even if you hit 80%, present 80%, go back. Find the people who are the experts, find them early. And I do mean data producers. You often talk to consumers, but if you can find people who use source system and created that data and know the history, I call them Janine because I've worked with two of these people, Janine that started in the beginning and moved on, basically worked their way up from data entry to owning the project. They know things, go find them. If you don't have access to them, go work with the BI practitioners, the data engineers, the people who do reporting, people who've looked at this data. They may actually understand the questions you're asking a little more, even if they may not remember some of the nuanced business rules. And at the end of the day, get used to being wrong. You're going to be wrong. Hopefully wrong means you're wrong about 0.01% of the data from something they did 10 years ago, not wrong about half the data. And again, the sooner you do that, the better. And again, can you relax any constraints? If there's, for instance, we had a lot of trouble, we had to only test in our staging environment, which had production data. You could not show that on sprint reviews because it had proprietary data and they recorded sprint reviews. We got them to stop recording sprint reviews. It was amazing. We were able to show, hey, no, this is the thing, because they wanted real data. Okay. Of course, this is my final call out to the folks who do business analysis and agilists, the agile, the process and people folks, not the technology folks. Technologists have your best interest. They just can't always explain it. For folks who are stakeholders on this, or the people who pay for the stuff, or at least kind of message the stuff out and help us out with the process. If your experts are telling you this thing is complicated or hasn't been done before, and it failed every time, listen to them. They may also be wrong. They may be assuming a lot of things over engineering, but please listen to them and figure out exactly why they're saying that and report that correctly. Resilience, please favor resilience. Especially for folks who are business analysts and project managers, understand we're talking about trying to build the earthquake-proof building as a thing that shakes. We're not trying to build a thing that's rigid and perfect like you would in waterfall. Thinking about like crossing the desert, sand dunes shift overnight. What might be like a 5-mile journey if you start today might be a 20-mile journey if you start tomorrow, because the landscape has dramatically changed and you literally can't go that way. You're breaking things down as much as possible, but remember, sometimes that is still in the complicated domain, not the simple domain like a lot of software engineering user stories. There's a great Quora thing out there if you search for it that is basically, I want to have dinner with my friends in Los Angeles. I live in San Francisco. It's a 4-day walk because it's 40 miles and I can walk 10 hours a day. 400 miles, I can walk 10 hours a day. The answer is no. If you read the story, they go to 5 days. The next day they're 10 days. And they're like, you know what, I give up. My feet hurt and I'm barely around the bay. So it's kind of like that. So kind of closing thoughts. Remember, DataOps, Agile is a huge component of it. Even when there are constraints, your improvements are constantly happening. You are more resilient. Everything you have done is that much better. Every data project is different. You can apply the principles of DataOps. Yes, there are constraints, but if you're applying deeply to the principles and not adhering to kind of a strict template that, that super rigid building that will fall down when an earthquake happens, go with that. Remember that you have to be open to change. And remember, most importantly, it's up to you listening to this and your teams who are cross-functional and whoever you're enabling, normalize the idea of DataOps. Kind of like I did that project. It's going live. Pretty much as I speak, I've moved on to another client, another contracting company that was with us has kind of taken it over because there was a lot more of them and our contract ended. It's close to done. It became a lot easier. We just set the foundation. We were able to train them on a lot of these principles. The next time this gets done, any improvements done on it will be that much more understood. It's the same for you. Please make this easier for all of us by applying these principles. And, again, one size definitely does not fit all, as I can show you with my cat right here. She thought she would fit in that box, like, any good data project. Your first assumptions are pretty much always wrong, and you need to reevaluate. That is it. Thank you all for listening.
Awesome. Thank you, Eric. And thank you, Jatin. Both informative sessions. With just 1 minute left, we do actually have just a 2-part question that you may need to answer when folks head over to the networking session. But the 2-part question is, can you apply the governance policies across cloud and on-prem environments? And how does the zone-based architecture work in a hybrid environment? So, Jatin, if you're able to actually answer it in 1 minute, go ahead. Or if
I'll,
not, continue that chat in the networking.
I'll take a quick stab at it. I'll try and answer this in the context of the end zone governance pattern, which was on slide 7. Because like I said, the zone is that central governance construct that you can define policies and expectations around. So when you talk about hybrid cloud architectures, there are many different variations of it. So I'll take a couple of examples. One is a customer with an on-prem enterprise data platform. It's around the operationalized stage in the data maturity model. So they have a centralized platform that handles acquisition, cataloging, quality controls, privacy, and they make trusted data sets available to their line of business internal tenants. The business unit data teams can then provision sandboxes in AWS, the cloud of the choice, for their analysis and refining and reporting. So in that case, referring back to that slide, the raw, trusted, and refined zones would be on-prem, while the sandboxes would be in the cloud. Another example we have is with the cloud-first data platform, and there's a few of them. And a common theme is that there are still data sources and business consumers which are still on-prem. So here parts of the raw zone and the sandboxes could be on-prem, but the rest are in cloud. Sort of the easiest way to think about, and just check me if I'm running over time. But the easiest way to think about how a zone is realized is to think of each repository of data as a database, and then the zone equates to a set of schemas. So,
Jatin, sorry to interrupt. You may need to just continue the answer, the response in the networking area, because we do have a hard stop and
Perfect.
we did go 1 minute over.
I
So thank you
understand.
again, Jatin and Eric, and thank you all for participating. So head on over to the networking.